So let's go through this problem. Koko eating bananas. The problem states that there will be n piles of bananas and the ith pile has piles I bananas, and Coco basically wants all those bananas, but the problem is that she can decide her bananas per hour eating speed of k. So each hour she will choose some pile of bananas and eats k bananas from that pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. Coco likes to eat slowly but still wants to finish eating all those bananas before the guard returns. Return the minimum integer k such that she can eat all the bananas within k hours, within h hours. Okay, so basically the task is that we need to come up with a value of k such that Coco can eat all the bananas within number of h hours, and h is given to us. Right, so if we look at the first example, then let's say that k was 3 in this case. If k was 3, this would take 1, this will take 1 hour, this will take 2 hours, this will take 3 hours, 2 plus 2 plus 3 is 7, and this will take 4, which is greater than 8. Let's look at number 4. This will take 1 hour, this will take 2 hours, this will take 2 hours, and this will take 3 hours. So the total is 8. So you get the gist of the problem. It's basically that we need to come up with a value of k such that Coco is able to eat that many bananas, number of bananas in h hours with the speed of k, right? K is in per hour speed, number of bananas Coco can eat per hour. So how do you start this problem? Well, a most basic solution which comes to our mind is that I will start from k is equals to 1 and then keep on checking until some value, let's say 1000 or whatever, and I'll start from k is equals to 1 and I will keep on incrementing the value of k. Once I reach to the point in which I can eat all the bananas, in which Coco can eat all the bananas in h hours, then I know that this is the minimum k which I am getting, right? So this is the first solution which is coming to my mind. So let's start coding that up. Okay, so I said that I will basically check all those values of k. So I'll start from 1, and what will be till what value should I check? Well, let's look at our constraint first. I don't see any. The maximum value of pile I can be 10 raised to 9, right? Maximum value of h can be 10 raised to 9, and pile length is a specific up to the size of array can be up to 10 raised to 4. Let's take any value, although we can pick, let's say 10 raised to 9, but that would be unnecessary for our case, because what is the maximum number of, when is this not possible? Let's say when the pile's length is greater than the number of hours, then we for sure know that it's not possible, like as we can see in example 2. If it is equal, and if it is equal, then whatever will be the maximum value in this piles of I will be my upper bound, because I have to eat a single pile in 1 hour. So I need that topmost speed, which will be the highest value in my array. So by this logic, I can say that, and it's always possible that Coco will finish the bananas. Although they haven't mentioned it, but they haven't asked us to return any value -1 or such, that if it is not possible. So we have to assume that it is always possible. So let's do one thing. Let's just take the max amount, max speed, which will be nothing but my, first I will declare it with int min, or it starts from 1, right? So I can have it 1 as well, doesn't matter. And now I will basically find the the highest value in my array. So basically max speed is equals to max of max speed and my current value, which is it, right? So I will basically have this max speed here, right? And so now I'm basically checking from k is equals to 1 up to some value, and whatever value I get in which it is possible, then I can say that this is my answer. So I will write some function here. Let's name it check. Okay, check for my k value will be passed, my piles will be passed, piles array, and my hr will be passed. Okay, so whatever this function returns me true, then I can have my answer as return basically my k, right? That should be my answer. And we can just return -1 here so that we don't run into any runtime error. Now let's, up to now I think things will be clear. So we are just running a loop from k is equals to 1 up to some speed, and we are checking one by one if this boolean value, if this boolean function returns true or not. If it returns true, then we are saying that okay, it is possible at this speed to complete all the bananas within HRs. So we need to write this function, right? That's the main problem here. So let's write this function. It will be int k. I will pass this entire thing here. And basically, so we have to compute something, right? So this boolean will either return a true or a false. When should it return true? When I can complete all my bananas, when I can eat all the bananas within HRs. Right, so the first step is to iterate through the array of piles. Int it of piles, I have to iterate. And then I have to also have a variable here which will be my current time. So my current time will be initially 0, but in the end I will just check if my current time is greater than 8, then I return greater than h, then I return false, else I return true, right? What is this current time? Current time in one, let's say the value was 3 in this case. If our k was 4, then we would eat it in 1 hour, because it says here that if the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. So we basically have to take a seal of it, right? So basically, if my it modulo k is not equal to 0, it means that this has a remainder. This is not a perfect square. Then what we will do, we will increment in our current time 1 plus my it divided by k. Okay, so it divided by k in this example, 3 divided by 4 will result to 0, and we are adding 1 because we have to take the ceil of it. Although I think there's a function also ceil in C++, but interviewers never like if you use built-in functions. They want to check your thinking or implementation knowledge. Okay, and if that's not the case, if it is else, if it's a perfect square, if it's a perfect divider, then we'll do current time plus is equals to it divided by k. Okay, so this function, I think it's complete. We'll of course run it and check, but this function will basically mean that now if our current time is greater than h, then we return false, because with that speed it is not possible for Koko to eat all the bananas in h hours. So Koko has to increase its speed. Let's run it and see if it runs fine. Okay, so we are getting a wrong result. We are getting -1. Why is that the case? Oh, it's because we also have to put equality sign here, because that speed can be equal, right? Okay, so this passes. If you submit it, I don't know if it will pass or not, because there can be a time complexity issue. But let's discuss the time complexity of this solution. What are we doing? What is the time complexity of this check? It's basically O of n, where n is the size of piles array. And what is here? K is running from basically 1 to some max speed. So max speed is the maximum value of our array. So in like, although it's a constant value, but still it's a large value. So you can say that this can be like, there is some linear complexity here, and the check takes O of n. So it's linear, some O of m times O of n, where m is the max element in my array and this one is size of the piles array. So it's a time complexity of m cross n, which is a lot because it will eventually fail. So we need to come up with a solution which is less than that. How can we optimize it is the question. We can't modify our check function because we have to check it individually. So what we can do is we can make this step a little bit quicker. How can we do that? Why are we checking one by one? Why can we improve on this? Because checking one by one is a waste of time, right? So let's apply something binary search here. Let me declare a answer variable first, and then what we do in binary search is we declare our high and low pointers, right? So my low will be equal to 1, and because this is my starting point, and my high will be equal to max speed, right? Now let me rewrite this whole function. So while same binary search thing, while low is less than or equal to high, we do int mid is equals to low plus high minus low by 2. This is my middle value, right? If check is true, let's say if check is true for this value piles and h, then I know for sure that with this speed mid is the speed here, with this speed it is possible to eat all the bananas. So I have found this answer for sure exists. Now I need to check if there's a lower value, because our task is to find the minimum integer, right? So which pointer should we move? We should move our high pointer because our search space has been reduced. So high is equals to mid minus 1, and let me just put it in here. and just for the sake, answer should store that value mid, and that's fine here. Else, if it is false, then what do? We haven't found. So whatever value will satisfy our answer is not mid, it is in fact higher than mid. So else would be equal to, which pointer should we move? Our low pointer, right? And in the end, we will just return our answer, right? So let's run and check if this runs. Okay, so this runs. So what is my modified time complexity? I converted basically my previous so-called for loop for k, which ran from 1 to the max speed, to basically log of m times. So I have, at every step I'm reducing my search space by half. So it's a log of m, and then check will take a linear complexity of n. So it's log of m times n. All right, so, and what is the space complexity? We are not using any additional space, so that's a constant value. Let's submit it. Oh, we're getting a runtime error. And why is that? We have this value. Okay. Signed integer overflow. So overflow basically happens when our computation is larger, right? So this value is exceeding what is allowed in integer, this value. So there are actually ways to solve this. I can initialize it with, instead of int, I can do long. That's one way of doing it. What are the other way to do it is that we can basically check if current time in is exceeding here at any step. We can just do h. So if my current time is exceeding h at any point, I return false from here only, so that we don't have to do the extra computation. Let's run and check if this runs. Okay, so this works. Although there was another thing which we could have done, is instead of int, we should have declared it a long. That would have also solved the problem, but I think this is sort of a better solution, because we are not, if you are making any variable long, or if you're converting its type, so a particular type is associated with a particular memory. So long takes more byte to store, so it takes more space in the memory. Let's submit it. Okay, so we did solve it. Thank you.